Okay, last one in our series of graphing quadratics, 7.2 graphing with intercepts. So our essential question is, how can x-intercepts be used to graph a quadratic? So far we've looked at vertex form, standard form, and now our last and final form, intercept form. So a quadratic function is written in factored form when it is written as y equals k, which is some value, x minus a and x minus b. Very similar to how you've seen everything when we factored it. So factored form, intercept form is when we factor it. So we have two functions here that are in factored form, and we're going to rewrite them so that they are in standard form. So we're going to distribute. So this 2 stays out here, and then I get x squared minus 4x plus x minus 4. Simplify, you get x squared minus 3x minus 4. Go and distribute the 2. And there is your standard form. Same thing over here. We're going to distribute. And we get x squared minus 2x minus 5x plus 10. I'll multiply by 3. Simplify. You get minus 7x plus 10. Go and distribute your 3 in. And there is in standard form. Determine x-intercepts and zeros of each function. So the factors indicate the x-intercepts. Well, we're already factored, which means we can then just set each factor equal to 0 and solve. So add 1, you get x equals 1. Add 3, and x equals 3. So those are our factors. Now our x-intercepts will be 1, 0 and 3, 0. Because what we did is we really substituted 0 in for y, which then allowed us to write our x minus 1 equals 0 and x minus 3 equals 0. So to graph, we then want to plot those points. So we have 1, 0, and then 3, 0. And then we know our vertex is always in the middle of our intercepts. So they're going to be on this line here. So we know the x-coordinate of our vertex is going to be 2. So let's find our y-coordinate. Well, we do that by substituting it in here. So we get 2, and then I get 2 minus 1, and then 2 minus 3. So we get 2. 2 minus 1 is 1. 2 minus 3 is a negative 1. So 2 times 1 is 2 times negative 1 is a negative 2. So our vertex is at 2, negative 2. So that'd be that point right there. And then there is our parabola. All right, so now let's look at the characteristics of our graph. We got a little bit cleaner graph looking here. So our vertex we already found on the previous slide. Our vertex was at 2, negative 2. You can see that again right here. That is also our axis symmetry, so x equals 2. Our y-intercept is hard to see, so what we're going to do to get our y-intercept, we're going to substitute 0 in for x. So you get y equals 2, 0, minus 1 0 minus 3. So you get 2 times negative 1 times negative 3. So 2 times negative 1 is a negative 2. Negative 2 times negative 3 is 6. So we'd say our y-intercept is 0, 6. All right, and our x-intercepts are a little easier to see. They're right here. And they also come from our x minus 1 equals 0 and x minus 3 equals 0. So solve and you get 1 comma 0 and 3 comma 0. Notice on the x and y intercepts, I always write them as coordinate points. Then our domain and range. So we'll go domain first. So our domain is from negative infinity to positive infinity. Our range, writing it in interval notation, goes from negative 2 to positive infinity. And a lot of you have written it like this in inequality, which is totally okay. Y is greater than or equal to negative 2. Since it is concave up, we have a minimum at y equals negative 2. Okay, so another one we want to graph. So let's start by plotting our intercepts. So for x minus 3, we get positive 3. And for x plus 5, we get negative 5. Now to find our vertex, we need to find our x-coordinate. Remember, that splits the difference. And so an easy way that you can do this, there's two different ways. Some of you will just count. So 1, 1, 2, 2, 3, 3, 4, 4. So then we know that the x-coordinate of our vertex is at negative 1. Another way you can do this is find your midpoint. So you take your 2 points, so negative 5 plus 3, and then you divide that by 2. So negative 5 plus 3 is a negative 2, divided by 2 is negative 1. So just two ways you can do that. And then since we know that our x-coordinate of our vertex is a negative 1, we're going to substitute that in to find our y-coordinate, and we get negative 1/2. And we get negative 1 minus 3 and negative 1 plus 5. So negative 1/2 times a negative 4 times a positive 4. So negative 1/2 times negative 4 is a positive 2. And then positive 2 times 4 is 8. So then our vertex would be at negative 1, 8. So there's our negative 1. Here's our 8. And which, as we draw this, should make sense because we are negative for our a value, so we're concave down, which matches up to our graph that we drew there. So same deal, going through and find our characteristics. As we already saw, our vertex is at negative 1, 8. Our axis of symmetry is at x equals negative 1. I'll come back to our y-intercept. Let's go x-intercept. We already know is at negative 5, 0 and 3, 0. Our domain goes from, I'll write an interval notation this time. Let's go negative infinity less than x less than positive infinity. And then our range is going to be y is less than or equal to 8. Since we are concave down, we have a max at y equals 8. And then so for our y-intercept, again, we're going to substitute 0 in. We get negative 1/2. And then we get 0 minus 3, 0 plus 5. So then you get negative 1/2 times the negative 3 times 5. So the negative 1/2 times negative 3 is a positive 3 over 2. Still times 5, which you put over 1. So then 3 times 5 is 15. 2 times 1 is 2. So then our y-intercept is going to be at 0, 15 over 2, or 0, 7.5, which if we look over here, it's about where that is on the graph. Okay, discussion that we'll have in class is how many x-intercepts can quadratic functions have? All right, now we want to write quadratic functions given x-intercepts. So our formula for this is y equals k. The way they do it, going back to what we normally have been doing, that would be a, and then our x minus a is what you'll see a lot, and then x minus b. It's one of the reasons why in this form they'll put k here, just so it doesn't get confused with the a inside there. Essentially what it comes out to be is you get y equals x minus your first value, which is 2, and then x minus your second intercept, which is 5, and then your k value in this case is 1. And then if that was it, if we wanted to write in standard form, we would distribute. So I'd get y equals x squared minus 5x minus 2x plus 10. We have 1 here, which really doesn't do anything for us, so we can just leave that 1 off. So combine like terms and you get y equals x squared minus 7x plus 10 if we wanted in standard form. So let's try another one here. So you get y equals, our k is a negative 3, and then you get x minus your first one, which is negative 3, and then x minus your second one, which is 4. So we get negative 3. Simplifying here, 2 negatives make a positive. Then when we distribute, we get x squared minus 4x plus 3x minus 12. And then this time it's multiplied by negative 3 still. So distributing that negative 3 after we simplify, first our like terms, and we get negative 3x squared minus x minus 12. Now we can go ahead and distribute that negative 3, so we get negative 3x squared plus 3x plus 36. And that would be it in standard form. All right, so now given a graph, so we can start out y equals our k, x minus our first one, which is a negative 2, and then x minus our second one, which is positive 4. So then you get y equals k, x plus 2, x minus 4. Then we have to choose another point. So we have this negative 5 and 9, so I go 9 equals k, and then you go negative 5 plus 2, and negative 5 minus 4. Now some of you may want to distribute out and get in standard form first, or you can do it this way. I prefer this way as we work through this. So I get 9 equals k, negative 5 plus 2 is a negative 3, and negative 5 minus 4 is a negative 9. And then we get 9 equals k, negative 3 times negative 9 is a 27. So we get 27k. Divide by 27. and k equals 9 over 27, which is 1/3. So then our equation would be y equals 1/3 x plus 2 and x minus 4. And then if need be, we could distribute this out if they asked to put it in standard form. So we'd have 1/3 x squared minus 4x plus 2x minus 8. So then 1/3 x squared minus 2x minus 8. And then distribute that 1/3 in. So you get 1/3 x squared minus 2/3 x minus 8/3. And now it's in standard form, if that's what we're asked to do. Reflection question here: what would the factored form look like if there were only one x-intercept? Okay, so think through that. Think through the graphs, what it looked like graphically. If you want to play on Desmos to play around with that as well, you can do that, and we'll discuss this in class. All right, then you have your quizzes. Then brings us to our essential question: how can x-intercepts be used to graph a quadratic? So think through the process that we've learned in these notes of how we can do that. And then your assignment.